Okay.
I think I've actually asked most of the students to cut off my intros because it's like the same every time, but no, that's fine. Hello, everyone. I am Rhonda Holberton. I teach in the Digital Media Art Department, and I am working with Kohar and a few other faculty members on an interdisciplinary collaboration called Wish You Were Here. It's part of a larger project called the San Jose Story Map, and the kind of conceptual conceit of the story map is that we get a lot of our kind of there's a lot of reality making that happens through digital platforms, and those digital platforms are not necessarily moderated for kind of content, or proportionately moderated by algorithms to highlight certain types of content. And so we were thinking about ways that we could kind of use other types of data organization to help tell stories about what it means to live and work in San Jose. And so what we kind of fell upon was using the idea of the scrollable story map to organize content contributions to this kind of social media feed, these small vignettes that are these mini portraits that kind of tell the story of individuals living and working in San Jose, and then using geography to help kind of organize the feed rather than an algorithmically driven kind of preference organization based on kind of user data and preferences. So it's a kind of a mashup between Instagram and Google Maps. The story map contest will start taking submissions next semester. And so as a precursor to that, I'd been talking to an interdisciplinary team, and including Kohar and our gallery director at San Jose State, the Thompson Gallery director. And we kind of talking about, the closure and what it means to not be able to kind of be physically co-present on campus. And then thinking about utilizing correspondence, and in particular the postcard, as an agent that can kind of slip between a physical agent that can kind of navigate networks, almost like a digital network. And so we're using the postcard format to kind of beta test submissions, but then also we'll be running an exhibition of these postcards in spring of 2021 in the Thompson Gallery. And so Kohar has been working with her students, I know a lot of you are here today, on iterative design concepts for kiosk displays that could be sustainable. And you're going to talk about this a little bit. So I will not talk about what those kiosk designs are because you will do a much better job. But those will be in the gallery, and then also will allow kind of the community to take postcards, and then will also be a receptacle where the community can contribute their postcards once they've kind of made their submissions. So that's the kind of bare bones of the project. If you're interested in finding out more information, you can, I think probably Kohar shared this. I'll leave this in the chat, but it's a long, because it's San Jose State, of course, everything's really long. There's a website that kind of talks about the workshops. If you missed a workshop but were interested in the content, they are being recorded. You can find the archives of the workshops here. And then there's also the link to the submission form for the contest. So there's instructions that will kind of walk you through like there's some templates that you can use for the contest submission, and the submission instructions are here. Sorry, I kind of lost myself while I was scrolling around that beautiful website made by student volunteers here. So there's links to the submission form, and then we have a couple templates that you'll need to use for your designs. We encourage interdisciplinary designs, and this isn't just about kind of 2D designs. These could be photographs of prototypes. It could be photographs of like performative actions. It could be a lot of things. And so this will be a curated selection of 10 postcard designs that are front only, and then 4 away form so that I'm gonna stop my share here, so that they become kind of like these unique limited edition art objects that you can take from the kiosk, and then you have a piece of the exhibition with you. That was a much longer intro. That was more of like a preamble than an introduction, but thanks for letting me kind of ramble on there.
No, that's great. That gave us enough time to make sure everyone's here. I feel more confident that we've allowed everybody who's going to join.
Perfect.
So thank you all for joining. I recognize some of my students, and I just got the introduction to Sabrina, but I'm also curious who else is on the call, what other disciplines or majors, just to know who I'm speaking with. Lauren, what major, what department are you in?
Well, I don't know if you could get from the other people, but I'm also a digital media arts major who is working with Rhonda on a couple projects here and there and stuff. So that's where I work in 3D modeling with Maya, but I have dabbled with Fusion a little bit. So I still don't know all about what's here. So I really would love to learn about what's the capabilities of Fusion and all that we're using today.
Great. And I'm sorry if I mispronounced, but Yan Rong?
I also a DMA major.
Great.
And so I curious studies lecture.
Wonderful. So, and you guys are undergraduate, right? Okay. And then Ryan too.
Hi, Ryan. I'm an industrial design major, and I'm just dabbling in Fusion for my class in sustainable design.
Yes, thank you. So we have two Ryans. Ryan's in my sustainable design class, and Chloe, Seva, Ju Chen, and Daniel are all in my DSID 21 class, Visualization 1. Thank you for joining. And Ryan too.
That's me. Sorry. That's my
that's you.
computer.
Oh, okay, that's right. I forgot you needed to do that.
Sorry.
Great. So wonderful. Well, thank you all for joining, and I'm going to share my screen and start. Let's start here. Okay. This is my first time presenting from Google Slides, so I hope you can see my screen.
Yeah, it looks great.
Okay, great. So thank you for joining me for Iterative, Sustainable, and Generative Design. Today I'm going to go over some tools and techniques to hopefully help you unleash your creative process. My name is Kohar Scott. I'm an assistant professor in the industrial design program of the Department of Design. I was adjunct prior for about 5 years. My background is in industrial design. I graduated from Art Center College of Design and from San Francisco State a couple of years ago. I worked in corporations, small consultancies before starting my own design consultancy. My specialization is in CMF, color, material, and finish. I'm very passionate about how materials can help solve problems. So we're going to talk today about some of the methods we use to approach sustainable design. So why is it important? Well, climate change affects us all. We see this evidenced through global warming and the changes in our weather patterns. We as designers have responsibility that we can make changes through the materials we select. It's important to understand the effects of our decisions, and statistics on recycling are actually lower than what you might think. According to Great Britain's Royal Statistical Society, for example, since 1950, of the 6.3 billion tons of plastic waste that's been produced, any guesses as to how much of that has actually been recycled? Anybody?
5%?
5%? Well, that's great. Let's see. I'm going to try to navigate the chat as well. Much less. You know what? Actually, then I have great news.
Thank God. Pessimist in me saying today again.
It is grim, but it's about 9% according to the statistics. On average, it's typically pretty low, although we claim and it's marketed as a recyclable resource, so little of it actually gets recycled. So we emphasize in this class when we're talking about the potentials that are outside of, maybe the conventional material uses, for example. So we might not necessarily be decision makers, but we can be conversation starters. So we can start looking at and exploring and introducing different materials and thinking impact first before we hit the design table. In the design class, Sustainable Design, we started out at the History San Jose Archive. Has anybody been there out of curiosity? Have you ever heard of it? Maybe not. It's
the first time I heard of it was actually you and sharing. This is amazing. So thank you for including that.
Yeah, so they have an amazing archive. It's very vast, and they've been collecting products since, I believe, the 1900s, 1920s, and they're creating an archive of product history. So we started there to look at the products of the past and see what could we learn? What products stood the test of time? How were they manufactured? What materials were used? So that was our starting place. And it was also helping us to produce a baseline for comparison to improve for our future products. We have the opportunity that I'm really excited about. We've been working with the San Jose Story Map project and its other iterations to contribute to the San Jose Story Map project by designing 2 different styles of displays for postcard submissions. One display will showcase all of the submissions as a display only, and the second display will provide the opportunity for users to submit postcards on the spot through a kiosk style display. In my class, we are using a book called The Ocala Practitioner, and we started by using the eco-design strategy wheel to generate ideas and concepts. And so it started like this. So we have a wheel, and there are 8 different objectives that we used as brainstorming mechanisms to trigger ideas. The first one is innovation, and this is an example from the Quick Concept Iterations by John Choi. And innovation has to do with really thinking creatively about what the product should be and how it's reduced material impacts is a second category where the prompt is looking at how can you manufacture differently to create less of an environmental impact and less of a carbon footprint. And manufacturing innovation is what new and different ways could you think of to manufacture your products to also reduce environmental impact, reduce distribution impacts. So how do you get your product out in the world? What carrier mechanisms? Is it biodiesel trucks versus conventional trucks, or is it made locally? How can you resource local goods and reduce carbon impact by reducing the distribution impacts of your product? So those are some of the things in that category. Reduced behavior and use impacts. This is one of the hardest ones because designing for sustainability has to do with, a lot of it has to do with changing behavior. And that's one of the hardest things to change. Of course, from a sustainable design perspective, the most sustainable product is the one that's not manufactured. And but in this class, they have to design something that is tangible. And the exercises, because when we go out into the workforce and these students graduate and are working for companies, incremental changes can also benefit in huge ways on a global scale. So even just taking a material and changing it, while it might not reduce an environmental impact by 50%, it can make an incremental change that lasts, that leads to larger changes. So system longevity is another approach in that way. It would be taking the design and considering how to make it last longer, how to repair it, how to keep it from going into the end of life landfill. Transitional systems is another way to extend the lifespan of the product by making it expandable. How can you design something that can exist with a modification versus having to just chuck it? So the first phase is super important to keep. Sorry, I just lost my, hold on, let me represent. Okay. So the first phase is really critical. I asked my students to produce 94 concepts, which is a tall ask. And the way we went about it was by creating multiple concepts for each of those categories in the wheel, those 8 categories that we just looked at. The first phase, it's really about thinking on paper. My students will hear me talk about getting prolific. And what I mean by that is just don't think about it, just get the ideas out, suspend judgment. Usually the first 10 to 20 ideas are very common or obvious, and it takes some iteration to dig deep and get into more unique solutions. And it will pay off in the end for us when we're looking at a sustainable approach, when we really want to look at how can we really solve these problems. So my suggestion is that you sprint for 10 to 20 minutes and you set a timer. And then by sprint, I mean you sit there with a timer and you draw, pen to paper, 10 minutes, 20 minutes, and then you evaluate afterwards, stretch, and then repeat. So other techniques that students will use are random app idea generators, such as Spark or anddesignlab.com is also another one. And they'll just generate words that'll spark some brainstorming ideas, or maybe something that will inspire how you design something. I have some iteration. I like to start with some type of format. I don't know if you guys have experienced the blank page stare. It can be really intimidating to start with a blank piece of paper. So one way to start some momentum going is to have some templates. So at the end of this, I'll share this deck, and you'll have some links, or I think I can share this in the chat. Copy. And you can download these and use them for your sketch exercises if you find it helpful. Another iterative strategy is to refine your ideas by using previous sketches or photographs as underlays. I'm glad you guys appreciate the templates. So sketching over other sketches, and I apologize, this isn't the best image, but I couldn't find something better in the time. So sketching over something is going to help you to cut down time by using the perspective that's already generated, either from the photo or from your already existing drawing. So you could use a sketch that you have and make some modifications, and it's a good way to generate multiple ideas and keep going rather than having to start from scratch each time. So these are some examples from the students in my sustainable design class designing for the kiosk project. One thing I forgot to mention is that there are 15 students and they have 4 different design prompts. One of the groups is working on PPE, personal protective equipment. And then 3 of my students are working on the kiosk design. So this is work from Ryan Yukono, who's with us. And these concepts are also kind of a combination between John Choi, who was also thinking about these mobile, hanging mobile ideas, and iterated off of that in a 3D format. There's something magic that happens when you see something in 3D versus 2D. So we've all heard the expression, a picture is worth 1,000 words, right? So a colleague of mine once said, a model is worth 1,000 pictures. So when you see something, it sparks something else. It becomes more tangible. You can evaluate the proportions and scale. And whenever we can do that early, it's really valuable because that can also lead to improvements and reduced material waste on the production side. I can't tell you how many times the conversations with engineers or manufacturers have been greatly benefited by just taking a foam core mock-up and showing it to them and saying, okay, this is the best position for the knob. It's going to be here. So having a mock-up is really valuable in so many different ways. So another strategy is to use your photos or CAD models as an underlay, and that'll help you time to keep sketching and iterating by not having to construct your perspective each time. I typically, let's see if the animation starts automatically. Okay, do you guys see this animation?
Yeah, it looks great.
Okay, so I typically discourage students, and in our ID process, we discourage from jumping into CAD too quickly because we want to conceptualize more than create realistic models. However, Fusion 360 is comparable to what Autodesk's sketchbook. It's like sketching and drawing in CAD. It's a very iterative tool. It is very fluid, and it's not like some of the other software that take a lot of time to construct, and you really have to know what you're building. You can build very freely, very quickly in Fusion. And so that's part of the premise for this class. We've never used Fusion 360 in our program. We've been purely SolidWorks. And in industry, it's typical to use SolidWorks, but it's very constraint heavy. So you really have to know what you're designing. So this is a true experiment for us in a lot of different ways to see how this tool can help benefit our process. It's used a lot in different industries, and I have also heard automotive and aerospace has been using some of the tools, particularly, we'll talk more about it, but this is what you're seeing is generative design. So the animation that you just watched is the computer algorithms figuring out the best geometry to solve the problem. This particular chair was commissioned between Cartel and Autodesk and Philippe Stark. So he put in parameters into the software, and then these are the geometries that are iterations based on how the material can be removed to produce a very efficient, lightweight, but strong in the right places model. So it can help us visualize and help us think impact first, early in the product design phase.
Can I ask a question? I've never used like the generative components in Fusion 360, and I can't help but notice, and maybe I'm just overlaying on top of it, but they all look like his chairs. So like how much of that is like, is it trained like a neural network, or is it more just like the simple kind of constraints that he put in will always design a chair that looks like his signature chair?
That's a great question, and that's a great critique, and that's exactly why I think we're also playing with this this software and this feature, is to really see how can we utilize it. And it is typical to see that, and part of what's going on is that the material is remaining in the places where strength is needed. and then it's removed where it can be lightweighted. I wish I could give you a more technical answer, and actually I could follow up with our technical team. I will ask that in a follow-up because that's actually the criticism that I've heard. And I'm curious to see how we can use it for inspiration. That's part of what we're also looking at, is not necessarily being literal about its use, but how can it be an inspiration? And I'll go into that more in a minute as well. So the reason why and why I got so excited, despite the criticism of the spiderwebby kind of alien looking forms, the reason why it really dovetails so well with sustainable design is that it really is about lightweighting and strength optimizing. And there's a feature that is also a cloud generated data called it's a priori, that calculates material costs. And while there's limitations to, it's not like all of the exotic materials are necessarily in there, it's still very fascinating to me to be able to have a workflow that goes into the algorithms of like what the computer is suggesting, and then having output and data into the cost of manufacturing material or a model in that method. And what also impressed me was when I saw students work in other schools with this software, I noticed that there was a very dramatic shift from not knowing about materials and manufacturing to, at the end of working with generative, being able to have intelligent conversations about it. And part of the reason why is because it forces you to think about materials and manufacturing first instead of last. So this workflow is an example of how we would typically see design go from concepts to manufacture. And what happens is the design is pretty much finalized before it goes to the manufacturer. And at that point, making any changes is going to cost a lot and change the timeline to production. But having this generative component in the beginning allows for viable options, even though they might not be desirable, but viable options based on metrics input into the software, such as for additive manufacturing or milling or die casting. So it's limited, but my intention and my curiosity in this is to introduce it into the product design workflow, and how can it inspire us, or how can it help us to think about sustainability first instead of last. So turning the whole process upside down is really what it's going to take to create more sustainable design practice, but it's very challenging to change without a tool. And this is where I am excited about the potentials, even though I think there's still some ways that it can be improved. And so this is where it fits into our product design development. So for example, the left side, the green example, is how an engineer might design the fork for a motorcycle. And then when you go into the generative component, you choose a manufacturing method. You're forced into those choices to think about it. And then a material. And all of those generate different results. So you can see here at the bottom, the results are different geometries based on the manufacturing method and the material input. So why is that important? Well, it can mean the difference between something that is lighter weight and strength optimized. The shipping costs are impacted. The material carbon footprint can be lower. So those are all benefits to the process. And that's the intention and some of the excitement that I have about generative design. So my students are starting to implement these tools. They're working in Fusion and modeling from the iterative steps that you saw before. Now they're modeling quickly into Fusion, and I've asked them to incorporate generative design, like I said, not necessarily as an end solution, but looking at it for inspiration. So this is one of Ryan's latest designs, and he's also looking at how could he lightweight and remove material in this model. So I will stop my share and ask Ryan to show some of his iterative results from his generative studies, which are kind of wild, but still the same. Same spiderwebby look.
Yeah. Oh, I can't. Can you? It says disabled participant screen sharing.
Did that work?
Enable. Yes. Okay. Let's see. I'm gonna go to my Autodesk. Okay. So that's not it. Here we go. So that booth that we saw earlier are individual panels, L-shaped panels, really. And then they're all going to be kind of stacked together to create that booth shape. So with generative design, I can see how to lightweight the panels to make it even lighter or less material. So it's actually calculating right now what routes work the best. So if I click on this one, Fusion came up with this idea where it's again webby, but it holds the same amount of strength to hold the panel itself up. It looks funky, but it gives me an idea like where I can maybe cut holes and get rid of materials. This is an acrylic, that's why it's white, so it's hard to see. But I have these holes are for the support bars that we're going to hold up the panels. So I want those there, and then the AI figures out where the material can go and where it needs it the most. So it's saying like, oh, you're going to need some material here, but not so much out here. And then this is going to be like a support structure that goes all the way down to the bottom. Some of them comes up with funky ones like, oh, the whole thing just needs to be solid, but that's just an idea that it gives you. And then there's like a bunch of other generated concepts. This one's, again, more webby, but it kind of gives you the idea of what needs to be structured and where I can go to add more material or less material.
So one of the ways that I'm thinking, and I suggest to the students to use it as an inspiration, is look at where the software created the spider webs and optimized the contact points, and then modify it, which is what is really interesting about the way that the software is generating the data. It still can be taken into the parametric space afterwards. So once it's generated, you can actually go back and then create parametric geometry on top of it. So you can modify it and take it out of that spiderwebby world, theoretically. And that's what I'm excited to see. You know, how can we do that? How can we take the suggestions and apply design principles to it, essentially? Because that's, I think, part of what's missing and what we're seeing is lacking in the generative solutions. So let me go back to my...
While you're doing that, there's a science fiction writer that uses an AI chatbot that he kind of trains for his characters, and like won't use the text like copy paste, but like uses it in the same way, like it's a foundation for kind of exploration, and produces. He talks about it producing conversations that he wouldn't necessarily kind of write intuitively, and I think that that's such an interesting design paradigm.
Yeah. And that's, I think, part of where I think the value of this work is, because the conversations that we have in design is that, we, well, let me stop this share first so I can keep my train of thought. It's about capturing ideas quickly. That's the holy grail, is how do you really, because they're constantly coming through. And so we learn drawing skills, right? And I don't know if you guys start with a drawing foundation in DMA, or is it all software based? I'm kind of curious.
The program, yeah, it has foundation courses and like 2D concepts, 3D concepts. A lot of students, actually maybe Sabrina or Lauren can speak to this more directly, because I know it just looking at paper. I don't know it being in the classes.
Do you do do you start on the drawing table when you start working?
At least for me, I'm like foundationally paper to pen and pencil a lot. I went to community college for 2 years. We had to do like foundations of drawing, 2D, 3D, and I took 3D in San Luis State and I transferred. And we did sculpture. But now we don't have to take it, but I love the class because I love working with my hands and then bringing it into a 3D space because I can like visualize it. But Lauren can talk more, I guess. But yeah.
We do learn the basics of 2D and 3D concept, and for the sculpting class for Art 68, we learn how to weld. So it's really interesting interacting with materials that I wouldn't personally use before and seeing what that could help inform my design as well.
So a lot
Wow.
of our classes in DMA would be code based, and right, so like thinking about how do you sketch in code, right? So there's like writing it out in kind of like, you know, natural language, like what is the logic, and then kind of writing through pseudocode. And then in my Art 102, something that I've started to do, especially when we moved online, is ask students we really have leaned into iterative design. So I have them, you know, they have to come up with a minimum of 3. It's not 100. So now I'm like, man, I should have them like do 100 sketches, but I have them come up with like 3, you know, like do their brainstorming, come up with 3 that they then present to the class that we workshop together. And then we bring those like ink and, you know, pencil and paper drawings up to higher resolution and do like mood boards, storyboards. Yeah.
Nice. So it really has to do with that drawing table, that first start, because the quicker you can capture those ideas, you know, right? Because you're thinking of things. And that's why in our program, we really stress the value and the importance of learning 2-point perspective drawing and modeling and prototyping, because you want to be able to capture those ideas as they're coming through. So that's part of this conversation. So the next steps for us, and I'm super excited about this, and I'm super bummed at the same time that I don't have an example to share yet. But in the spirit of sustainable design, normally in our program we would be building physical models and prototypes, but I think there's a huge opportunity here to take our models and export them into AR prototypes and evaluate them essentially in you know, in that augmented state. So it's a great application, I think, for this technology to evaluate the kiosk designs. And that's what I'm hoping to do next. There's a export plugin from SimLab that plugs into Fusion, and there's a bunch of different ways to get to that AR file format, but that's one of them that I know about that we can use pretty seamlessly in our workflow. So let's see. Hopefully you got the link, and if you're able to download and you want to follow along. So Fusion and, well, a lot of programs I'm finding in Zoom get a little bit glitchy. So I've included this video demo with Jeffrey Smith from Autodesk in case my computer doesn't work. I'm going to go through this. The next part is going to be a quick demo in this fluid modeling space. And maybe I should share this in the chat. Stop share. Okay, I'll share this presentation. I don't know if I put the settings in right, if somebody wants to check first. Okay, so I will go into Fusion next.
Kohar, I think we need access to the presentation.
Okay. Mhm.
Lauren, have you used any of the AR plugins for 360?
Not in a while.
Is that what Steve's using?
I haven't taken his course in like 2 years, so when I first started, we didn't work with it.
Okay.
I took it last semester, but I never used the AR plugin. I never knew about it. Oh my god, if I knew about it, I'll be playing with it right now.
There's free versions and there's a trial version that is, I think it's like 30 days or something, but it's not even that expensive after that. Okay, sorry. If that, did the link, did the permissions work? I'll put a link directly to this video too in case it doesn't, let's see. Okay, so you can see my Fusion workspace.
Yes.
Kind of quickly, uh-oh, Zoom quit.
I know you were still here.
Don't.
Can you hear us?
Yeah. Okay, so this is, yeah. Let me try again. And I can also switch to another computer because I've just been noticed. It's kind of intermittent. I don't know what the problem is, but I'll try one more time and then switch. Or you can follow the demo on the provided link. Okay. Good so far?
Yeah.
Okay. So I'm going to start a sketch and I'm just going to start sketching using a spline tool, and I'm not doing anything really fancy or really specific, but this is to showcase how quickly you can just start to model and generate some geometry. So I've offset a line, and then I'm going to move and copy this by clicking on it and then just moving it up, and then I'll just twist it a little bit. And so this is going to be an end table, a very fluid, just organic kidney bean shaped table. So I'm going to throw some lines on there and just a few of these. And then I can create, so these are sketches now, and I can use these to create geometry by in the parametric space. So I can create pipes and I can modify the shape, thickness, and parameters individually. But what's really also exciting about this software is that they've incorporated this kind of more sculptural space, called sculptural workspace. And so if I go into this sketch session, then I can also create the same pipe feature, but it's going to be editable in a different way. So I'm going to modify some of these parameters. And then from here, this is what's also different, is I can go to modify, edit form, or I can select an edge. Edit form, and then also take some geometry changes that way as well. So I can quickly iterate into different forms without having to really know ahead of time what I'm designing and building. And that's really what's very different about modeling this way versus like SolidWorks, for example. So my sketches are still available. I can take this top and I can build I have to finish this first. So the sculpt space is an entire session. So it works a little bit differently than the other workspaces like Solid and Surface, but they're all kind of, they tend to provide a lot of freedom, and that's what I'm excited about, seeing how our students benefit from this versus the Fusion or the SolidWorks modeling that we use. So I've got this table surface, and then now I can go into the body feature and move it so that it is above the table surface. And then I can push pull and really very quickly change this geometry into a more recognizable table surface by using all of the sketches that I just built. And then I can go into the render space and assign some materials. And there's a library of a lot of basics. So I can make this glass, and then I can do a quick in canvas render to evaluate before it renders to the cloud. So with our educational license, we have access to generative design and also rendering in the cloud, so it's not taking up your computing space on your computer. I think the glass did not take. So I know I went through that really quickly. Quickly and easily, you can just start to create form and geometry. So it's still rendering, or it might have stopped. Do you guys have any questions?
Do you have the bandwidth and time and interest in showing some of the generative functions?
So the other part about the generative design aspect is that it takes a long time to compute.
Okay.
So it will, I think that it'll be better. Maybe that since he's already run the studies.
Yeah, are they like do they get cached with your Fusion files once they're run?
There's separate studies, and then you can take the solution that you choose, and then you can bring that into the workspace.
Cool.
Ryan, would you mind sharing your setup for your so it's basically preserves and obstacles. So you could theoretically not even have anything designed.
And we just like,
oh, did I freeze?
Run something?
What's that?
Your video froze. We can still hear you though.
Oh, okay. I think that's doesn't play nice with Fusion, unfortunately. Can you still hear me?
Yeah, I still can hear you.
Am I frozen in a really funky position?
No, in fact, you're lucky. It actually just turned black, so you're saved of the horrible freeze face.
So it doesn't work on the spot. It takes time to compute because
Sure.
it's taking all of the parameters that you input. So for example, Ryan can show you what metrics he put in. So you have to, and this is one of the things that I really appreciate about San Jose State is that you guys have to take physics. I went to art center, and so we got designer math, which is like, hey, we're happy if you guys can, you know, calculate, just work your checkbook. So
I
I
don't
think
know.
it's great that you guys.
Do you all have to? Do DMA students also? Everybody has to take it?
Not
Oh.
officially. You could take another physical science, but I took physics twice.
Because you're you.
Yeah, yeah.
Wow, that's great.
I got out of like math classes as soon as I could. I was in high school allowed to take computer science courses to count for math credit, and I was like, oh yeah, give me the code. I like all of the abstract
Wow.
stuff. I need an application, or my brain just like can't see it, or you know. Ryan, do you have
That's great though.
do you have a screen that you could share for at least like not the computation, but just the kind of UI?
Yeah, so here is the general layout. So yellow is like what I want the starting, it's called starting.
You don't have to actually, you don't have to do, you,
Oh, I
it's nice that
Mhm.
you don't have to, but it's nice that you did. And I think that can also benefit.
So the red is called a obstacle geometry, where if I
Are you
don't want,
sharing?
yeah, I'm
Yeah.
sharing.
Yeah.
Okay. Everyone can see it, right?
Yes, we can see it.
Okay, so the red is like where I don't want the branches or the AI to go. And so I kind of like, I have it like blocked off, kind of like you can see it in here. And the green is what I want to keep. It's the body and the shape that I want to keep. It's called preserve. And so, so the idea was like I was going to have this shape, this L shape, and then I was going to have bars or poles to keep it structural. So this obstacle, this red bar, was going to act as like that geometry. So then once you have all of that, you can go to your Explorer, I guess. Hold on. Okay, so and then it starts spitting out these results.
And the yellow is just kind of, you know, you don't have to have it, but that is like giving it kind of like a base. So here's this a form to start with, and then kind of run off of that. Is that?
Yeah, that's right. Correct. You're just telling it to like, this is kind of what I want, and then it'll do it for you. The rest.
And can you can you optimize for different variables like lightness or strength or you know?
Yeah, so then afterwards there's structural constraints. So like if you don't want something to move, and so I don't want these holes to move within the structure, so then you just lock it, and that's what the structural constraints are for. And then there's structural loads, which is it automatically includes gravity, but then you can also add force, downward force. Let's see, can you guys see that? Okay. So
And that's the physics part that I appreciate. You guys have a better understanding.
I have zero understanding in physics. So when I click on it, I'm just like, just do, I don't know, 20 pounds or something. And I just throw in a number. And then once that happens, you can choose like the materials you want. So then right now I have like plastic, acrylic, and aluminum. Oh, sorry. Before that, there's also like how you want it to manufacture. So there's unrestricted, which is the webby look, and then there's additive manufacturing, and then there's milling, and there's more down here, die casting and stuff. So I just have unrestricted, additive, and milling for now, and then you choose like the material you want, and you can just throw in. I had a limit. I think it was like 6 materials that I can just calculate all at once. And then once you do that, you just check if you have any issues. Some of them it'll tell you, but those aren't really, those don't mean anything. right now, and then you can do like a preview, and then you can like finally generate when you click on that. And then when you do this, it takes like hours, but these things start coming out.
That's amazing. That's so cool.
And then I think I haven't gone to this part. I think Kohar could show me. But like once you have like this, you can actually take it into the like you can actually mess with it. Like yeah, design from outcome. So I can just click on this, and then I'll create the design, and then it'll bring it back into your model making. But it also takes time. But like once that's done, this exact model with like a mesh that you can form and reform will come out, and then you can keep messing with the design.
That's so cool.
Yeah.
So we've also been experimenting with how do you take a scanned data and pull it in as an OBJ, and all of these different file formats, and they do work, and there's some work that needs to be done to get the triangulation, the polygon count to the size that it likes to work with. And so we've been also experimenting with that, and I think there's some more that we're looking forward to doing with scanning, although I haven't seen high enough quality from the apps to really make it usable the way that we need to. And I've been also using the other recap. Recap is the other one.
But you're using the app?
Well, no, recap is it's a stitching.
Oh, it's like a remesh.
Yeah, it will take the photos. You take your 20 to 100 photos, and then it'll stitch it together into cloud data.
Yeah.
And I've had better luck with that than the apps. And this is kind of new to our workflow. We haven't experimented with that very much in our program. So I'm super excited to learn from what you guys are doing, and also see how it can benefit our process as well.
We have a laser scanner, but we can't purchase the software that makes it super useful. So when I was teaching at Stanford, we had this, but it's called Next Engine, and they use it in like dentistry and jewelry. So it does like small objects really, really well, but you can also kind of put it on a tripod and like scan like room size models. And it's just it's both the kind of sensor data is a lot better than using like, RGB images, which are very mushy. It doesn't, capture color data that way, but it's definitely more accurate. But if you want to like go in together or like figure out a way, it's just not VPAT certified, the software. And so you get these like a series of these like cloud meshes that students like have to kind of like align by hand out of the box. But they do have like a proprietary like pro software that does the auto stitching. So if what you're looking for is like the capability of like creating usable parts from a 3D scan, that's a good option. But yeah, no, I mean, the way that we use 3D scanning, it's not, to create structural or usable parts for fabrication.
Well, and we'll have to talk more offline. But yeah, that's another conversation too. So I want to be mindful of time, and I can't believe this is probably one of my first like literally on time endings.
Well, thank you so much for this like overview. And I think even just kind of dipping our toes into this and seeing this kind of wide swath of practices and processes are changing the way that I think, and hopefully the way that students are approaching some of their kind of like art and design problems. So super exciting.
Great. Yeah, I hope you're able to take something away from this presentation.
Definitely. Thank you, Kohar.
Thank you all.
Bye.
Thank you.
Bye-bye.
Thank you.
I only caught the end, but that was really cool. Thanks, guys.
I don't know if this is still working or not. I'm trying to press stop record. I hope it recorded something.
Yeah, I hope so. Your video just completely cut out
Ugh,
like halfway through, or
halfway through?
when you were doing the table, like right afterwards. You got the table part, but something happened.
Yeah, I think it's my machine. It's not some, I don't know. Something's up. Let's see. I'm trying to end. Okay, so why don't I quit out and I'm gonna start up on the other computer that's not Foobar.
Okay. Do you want me to come back to this link?